Hi, in this short video, I will talk about how to write recursive function in Python. Suppose that you want to calculate the sum of a list of numbers such as 1, 3, 5, 7, 9. I want to find the sum of these numbers. You know how to do this with list using for loop and the accumulator. You've done that many times, but how to write a recursive function to do the same? Remember the three laws in recursive algorithm. You have a base case, try to break down the problem into smaller subproblem and move toward the base case. And recursive function must call itself. So to add a list of number, you recognize that you want to do 1 plus 3 plus 5 plus 7 plus 9. This really means 1 plus the sum of 3, 5, and 7, 9. And the sum of 3, 5, 7, 9 is 3 plus sum of 5, 7, 9. Take a look at each step here. And sum of 3, 7, 9 is 5 plus sum of 7, 9. And sum of 7, 9 is 7 plus sum of 9. And sum of 9 is 9. Ooh. And I stop the iteration. I stop the recursion. I know the sum of 9 is 9 because I know this sum here, 9 is 9. Then I can add 7 plus 9, which will give me 16. That means this would be 5 plus 16, which is 21. And this means this will be 3 plus 21, which is 24. And that means this will be 1 plus 24, or 25. As you can see, when I do the recursion, these are, you can think each of these bullets is like a step, the recursion step. And when I got to the base case, the data gets fed back up to the to the stack or to the step. So from here, we can break down the sum operation to smaller operation that call itself until we are at the base case. The sum of a list is the sum of the first element plus the sum of the rest of the element, the rest of the list. And the sum of the rest of the element can be found by recursion. The sum of the rest of the element is the sum of the first element in that list plus sum of that of the remaining element. And you stop when there's only one element, much like when we stop here. This is when we stop when only one element. Sum of 9 is 9 because I know sum of 9 is 9 without doing any calculation. And by doing that, I can write the recursive list sum function. If the length of the list is 1, then I return the first element. Otherwise, I return sum of the first element plus the sum of the rest of the element. And using the list slide method, I get from the second element to the end. And I can show you that in Python. So let's run this and debug this and go to console. Step by step, you can see num list going from 13579 now becomes 3579, and now becomes over here 579, 79, and now only 7, and it will now only 9. It will return 9, and at the end, the answer is 25. I prepare what I call a recursion stack diagram to kind of like put some indentation and how the stack work. And let me show you the output here by running it. The same program, I just add some step here, and let me moving up. Initially, I call list sum 13579, and then you will call list sum 3579, and then you call list sum 579, list sum 79, and list sum 9, and this return 9 to it. So these are kind of like what I call the stack getting unwind. List sum of 9, you return 9 because of the base case, and then this 9 get add to the list sum of the indentation. Check the indentation here. 9 plus 7 is 16, and then this 16 is add to the 5, which give you 21, and this 21 is add to 3, give you 24, and 24 you add to 1, give you 25. These indentation tell you these are the step, the recursion step, the stack, the corresponding stack. Alright, let's do another exercise. Suppose that you want to calculate the sum of numbers from 1 to n, like 1 plus 2 plus 3. Write a recursive function called sum that returns the sum of numbers from 1 to n. For example, if sum 10 is called, the function should return 55. Well, think about the three laws of recursion. What would be the base case? And how do you make the problem smaller? So given sum 10 basically sum of 1 plus sum of 9, right? And sum of 9 would be 1 plus sum of 9 would be 1 plus sum of 8. So let's do this here. So if I have a sum of 10, this means 1 plus 2 plus 3 dot 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 plus 10. And you can look at this like 10 plus 1. How about this? This would be like a sum of 9 plus 10, the first 9 number. And sum of 9 would be 8 plus, oh, I'm sorry, 9 plus sum of 8, until I got to sum of 1, which is 1. I know the answer. So let's try that. Let me put a sum R here. Again, this is just my template. I start the code to make sure no error. And the base case, if n is say 0 or 1, then just return the n. Else, I want to return the sum of n plus sum of n minus 1, the recursion. And I can do like 100 and run that, give you 50-50. Suppose that you want to calculate the sum of a list of numbers such as 1, 3, and then another list inside 5, 7, and 9. The list sum function will not work because of the nested list. I'm adding number within the list, but this will not work if the element in the list is a list. But how would you solve this? How to write an algorithm to sum number in a nested list? Well, a nested list is a list. So if you can find sum of a list, you can find sum of a nested list. And this is where the recursion really come in very handy. A nested list contains a list, and this is really a recursive idea. All we need to check if the element in the list is a list. If it is, then find the sum of that list. Otherwise, you add the element. So I could, using recursion, to find the sum of a list. In this case, yes, I do not have a if-else statement, but I combining the idea of a iteration and recursion. This is using the accumulator, and for element in nested num list, if the type function tell me what type of the data type is. So if type of the element is same as type of the empty list, which is a list, then I call myself again. Total plus equal list sum R. I call myself to find the sum of the sublist. Otherwise, I just add the element to the total and return total. And what's so beautiful about this is whether the list is a single list, a nested list, or a nested list. A list within another list. It doesn't matter what the combination of it. This will work. And this program would be hard to program using, say, iteration, because you don't know how many times you need to iterate. All right. Write a recursive function called multiple of 3 that calculates and returns 3 times n. How do you do multiplication? Think about how do you do multiplication. Well, let's try it. Multiple of 3 and number. Let me see. How about let's do a small, simple one. Let's do a 2 here, and let's run this with no error. And what is a multiplication? Back in the grade school, what do you know about multiplication? Multiplication is basically a repeat addition. So if I say multiple of 3, if I pass in 2, that means 3 times 2. If I say multiple of 3 and pass in, say, 10, that means 3 times 10. What that really means is multiple of 3 times 2, that means you add 3 plus 2. Multiple of 3, 10, that means you add 3 to yourself 10 times to get 30. So in this case, the base case, if n is equal to 1, so what is a multiple of 3 if n is 1? Well, you have 3. Otherwise, you will want to add 3 plus multiple of 3 of n minus 1 and see if you have a correct answer. So 3 times 2 is 6, and 3 times 10 is 30. Multiplication is like addition, and so this will work. Okay, think about this, take a look at that, and we will do more programming exercise during class to understand better about the recursion.